Okay, once again, remember, use this outline and it'll take you straight to your next section. Newton's second law. A car's gas pedal, like the one in the figure below, is sometimes called an accelerator. That's because it controls the acceleration of the car. Pressing down on the gas pedal gives the car more gas and causes the car to speed up. Letting up on the gas pedal gives the car less gas and causes the car to slow down. Whenever an object speeds up, slows down, or changes direction, it accelerates. Acceleration is a measure of the change in velocity of a moving object. Acceleration occurs whenever an object is acted upon by an unbalanced force. The car pedal on the right controls the amount of gas the engine gets. How does this affect the car's acceleration? Acceleration, force, and mass. Isaac Newton determined that two factors affect the acceleration of an object: the net force acting on the object and the object's mass. The relationships between the two factors and motion make up Newton's second law of motion. This law states that the acceleration of an object equals the net force acting on the object divided by the object's mass. This can be represented by this equation. Acceleration equals net force over mass, or A equals F over m. Direct and inverse relationships. Newton's second law shows that there is a direct relationship between force and acceleration. The greater the force that is applied to an object of a given mass, the more the object will accelerate. For example, doubling the force on an object doubles its acceleration. The relationship between mass and acceleration, on the other hand, is an inverse relationship. The greater the mass of an object, the less it will accelerate when a given force is applied. For example, doubling the mass of an object results in only half as much acceleration for the same amount of force. Consider the example of a batter, like the boy in the figure below. The harder he hits the ball, the greater will be its acceleration. It will travel faster and farther if he hits it with more force. What if the batter hits a baseball and a softball with the exact same amount of force? The softball will accelerate less than the baseball because the softball has a greater mass. As a result, it won't travel as fast or as far as the baseball. Hitting a baseball with a greater force gives the greater acceleration. Hitting a softball with the same amount of force results in less acceleration. Can you explain why? Calculating acceleration. The equation for acceleration given above can be used to calculate the acceleration of an object that is acted on by an unbalanced force. For example, assume you are pushing a large wooden trunk, like the one shown in the figure below. The trunk is a mass of 10 kilograms and you are pushing it with a force of 20 newtons. To calculate the acceleration of the trunk, substitute these values in the equation for acceleration. The formula for acceleration is A equals F over m, so you would just plug in these two values. Up here it gave you 10 kilograms for mass, so that's going to go down here, and it gave you a force of 20 newtons here, which results in 2 newtons over 1 kilogram. Recall that 1 newton, 1 N, is a force needed to cause 1 kilogram of mass to accelerate at 1 meter per second squared. Therefore, force can also be expressed in the unit kilograms times mass over seconds squared. This way of expressing force can be substituted for newtons in the solution to the problem. Acceleration equals 2 newtons over 1 kilogram, which also equals 2 kilograms per meter per second squared over 1 kilogram, or 2 meters per second squared. Why are there no kilograms in the final answer to this problem? The kilogram units in the numerator and denominator of the fraction cancel out. As a result, the answer is expressed in the correct units for acceleration, which is meters per second squared. Acceleration and weight. Newton's second law of motion explains the weight of objects. Weight is a measure of the force of gravity pulling on an object of a given mass. It's the force in the acceleration equation that was introduced above. This equation can also be written as the acceleration due to gravity of an object equals 9.8 meters per second squared. So if you know the mass of an object, you can calculate its weight as You do not need the rest of this for the work today, so you can just skip over it.